Well, this is the part 2 or the second video for optimization, which is applied in profit maximization. In the part 1, we have discussed that in profit maximization, to maximize profit, the first derivative of the profit equation should be equal to 0. That's the necessary condition. And the sufficient condition is that the second derivative of this profit equation should be less than 0. Now, in this video, we're going to see the application in a specific cost and revenue equation. Let's see the next slide. This is the example that we're going to see the application for maximizing profit. This is the revenue equation, 2400Q minus 5Q squared. And this is the cost equation, q cubed minus 65q squared plus 3000q plus 1800. And then we can find the profit function, the revenue here, which is coming from here, minus the cost function. So this is the profit equation. Minus q cubed plus 60q squared minus 600q minus 1800. And then now we need to apply the necessary condition. The necessary condition is the first derivative of this profit equation should be equal to 0. Or in the part 1 of our discussion, we have discussed that this necessary condition, which is the first derivative should be equal to 0, is the same as the marginal revenue equals the marginal cost. And then this is the first derivative of this profit equation, minus 3q squared plus 120q minus 600 equals 0, because the necessary condition says that the first derivative should be equal to 0. And then the q, the square root of this equation is, the first q is 5.85, and the second q, the second quantity is 34.15. So we have two values for quantity here, 5.85 and 34.15. And now let's apply the second condition, which is the sufficient condition. The second derivative should be less than 0. This is the first derivative, so the second derivative is minus 6q plus 120. This second derivative should be less than 0. Now let's find the second derivative by substituting the first quantity here, 5.85. When this 5.85 is substituted in the second derivative here, so we can see here that the result is 84.9, which is greater than 0. Because it is greater than 0, so from our discussion in part 1, we know that 5.85 is the quantity that will minimize the profit, not maximize, but minimize the profit. So when this 5.85 is substituted into the profit function here, the profit equation here, we can find that the minimum profit is negative 3,427. This is the minimum profit. And then let's see the second quantity, 34.15. When this 34.15 is substituted into the second derivative, we can see that the result is negative 84.9, which is less than 0. So we know that because the second derivative is less than 0, this is the quantity that will maximize profit. 34.15 is the quantity that will maximize profit. So when this 34.15 is substituted into the profit function, here the profit function, then we can see the result is 7,857. this is the maximum profit. Now, let's see the diagram illustration in the next slide. The results from the previous slide are summarized here. So this is the profit function. We know that it is a cubic function here. The q is cubed here, cubic function. So from our understanding from the previous chapters, we know that because it is a cubic function, we can expect that at maximum we can have two extrema, minimum and maximum. Okay, and then from this equation we can also see that when the quantity is 0, the profit is negative 1800. So the vertical intercept of this profit diagram, profit curve, is at negative 1800. And then we also have found that the quantity that will minimize profit is 5.85, and the minimum profit is 3,427, and the maximum profit is 7,857 when the quantity is 34.15. Right? Now let's apply these results in the diagram. This is the vertical axis for the profit, the horizontal axis for the Q, and we can see here that when the quantity is 0, the profit is negative 1800. So the point is here, negative 1800, and the minimum profit is negative 3,427. So it is here. When the quantity is 5.85, the profit is at minimum, and it is negative 3,427. And then we can also see that when the quantity is at 34.15, here 34.15, the profit is at maximum. The maximum profit is 7,857. That's the example that we can discuss in this video to show how we should maximize profit using the necessary and sufficient condition. Thank you. I hope this video can be useful to understand more about optimization, and thank you again.